Hi everyone. Good afternoon. Everybody's set? Perfect. Before I start off, I'd like to have a little thank you to the organization here. So maybe a round of applause because we haven't done so yet. Yeah. So this is a bit of a home match for me. I have been part of the R community here in Amsterdam for about 5 years now. And I think it's absolutely fantastic that we are having an event like this. Well, after maybe a little bit too long, but it's great we have this. I also would like to have a sincere thank you to Go Data Driven for sponsoring the venue. I've not been working with you two guys, but with some of your colleagues, and I think you're a great company, and I really think it's great what you do here in the open source community. Unfortunately, mostly Python, but this makes it up at once. So, thanks, guys. So, who am I? My name is Edwin. I like traveling. That's me in the mountains, in case you were wondering. I like traveling to mountainous places. Probably you crave what you don't have at home. I like to travel to cities along. So you will find 2 or more vacation pictures from me in this presentation, so pay attention. This is also me with my little baby. So I spend a lot of time with my family. And this week he was so nice to bring a little present home for Daddy. So I have a really nasty virus now. So I'm barely hanging on here. So if I stop making sense during the presentation, please intervene. But I'm fully drugged up, so I hope I can make it to the end. So I like traveling, I like time spending with my family, but mostly I like to do this. I'm fortunate enough to spend about 90% of my work time typing R code. The other 10% are SQL or meetings, which are equally worse. That's not true. I like both actually. And I work as a data scientist here at Funda here in Amsterdam. And just a quick show of hands, who knows what Funda is, what the company is? All right, that are all the Dutchies. So, and everybody else, welcome. Great you made it here to Amsterdam. Funda is the housing site in the Netherlands, so everybody who has a house for sale posts it on this website. So for Mara, that's Zillow. For everybody from the UK, that's Zoopla. And for everybody else, you probably have a website like that in which listings are posted. So that's where I work now for a few months. I am a graduate in applied statistics 4 or 5 years ago. I blog, so where for some people Twitter is their medium of learning out loud. For me, that's blogging. That's why I actually look at new concepts and explore things. This is my Twitter handle, which is then probably less interesting. And on CRAN, there are 3 things I work on. So I'm the author and maintainer of the Pattern package, which some of you might have heard of, might have used, which is for preparing time series to do time series analysis. And I also contribute to the GGLI package, which is basically ready-made out-of-the-box functions that build on top of ggplot. And also recipes, which you might have heard about, a very nice package of Max Kuhn. So I contribute a little bit of it to that also. I did a talk on recipes a few months back at ERAM, so if you're interested in that, you can find it on YouTube. So what's this talk about? Yeah, that's right. Yeah. This is the first vacation photo I took into this presentation. You probably have no idea what it is because it's very dark and basically it's not a very good photo. But this is the main square of Portland, Oregon, which I visited a few years back together with my wife. I think she was still my girlfriend then, but no matter. And there was this big event going on called Flicks on the Bricks, which showed the movie Grease, and it was a sing-along. So I would call this a learn-along, so a little bit maybe analogous to learning out loud. So this is something I'm learning. It's something I'm not an expert on. It's something I was deeply nagging me that I didn't know what it was about, non-standard evaluation in general, for many, many years. And so this is something I've dug into about a year ago. I did a blog post, I think, last September, so that's exactly a year ago. And I wanted to know what it was. And so basically this is the result of that. That means I'm not done learning yet, so I'm not an absolute expert on anything I'm going to talk about, but I think I've got it more or less figured out, so I hope I can learn something, so something I've learned you can learn too. So let's show some hands. Who is very experienced using non-standard evaluation? Who thinks I have this pretty much figured out? I know what it is. Great. Because otherwise you could learn me to teach me, so that would not be great if the full audience would raise their hands. Who applauds it now and then, has kind of a feeling what it is, all right. Only knows it at face value. And who is not really sure what it is. Perfect. I have something to teach here. All right. So why do we love R so much for data analysis? Probably one of the main reasons is because we don't have to use R when we use R. I think that's one of the great reasons for its success. There are many, many other things that actually contribute to the high success of R with the interactivity, with the interactive use. So instead of this, right, on top, which is the base R version of adding a column based on a preparation based on two other columns of data frame, we can do this with dplyr, which we know all about thanks to Suzanne. Or I'm not going to start any flame wars here. So I also include data table examples. I'm just to give you a heads up, I'm a tidyverse lover, so I don't use much data table, but if you're more comfortable using data table, then that's fine. Right, so these are, I'm sorry, that's not where I was heading right away. So these dplyr and data table, that's what we call domain-specific languages. So there are languages created to do a specific task. So both are implemented to do data wrangling. And there's also, of course, ggplot. And basically, they are constructed in such a way that they are very easy to use interactively and taking more or less shortcuts. So they're really, really easy to use. And we all use non-standard evaluation from the first day we use R, from the first script we wrote, because we called library like this. So a little bit self-promotion. I take Pattern as an example for package. So probably, maybe you don't even remember the first day you wrote an R script, but you probably mixed up, well, install packages, and then you had to put the package name into quotes as a character. And then when you called library, you didn't have to use those quotes. So probably you mixed it up or didn't really understand why there was the one, why it worked without quotes or with quotes in both instances. And apparently, things that are not ought to work in R do work, right? So when we call these functions from ggplot or data table, or even from base R, the subset functions, we call variables from the data frame we're calling a function on, but we call them as if those variables exist in the environment we're working in. So that's a bit strange. So you use probably, so quick show of hands, who does using some non-standard evaluation packages like data table or dplyr or anything? I think almost everybody, right? The ggplot. So you use it. Why should you care how it works? So it apparently does some black magic there. You can put in the bare names of your variables that are actually column names that don't exist in the global. But why should you care how it works? Well, I think this is at least one of the reasons, because You're here in a dark room in the middle of a sunny day in Amsterdam, so you could have done museum visiting, you could have took a tour on a beer bike and be pissed drunk by lunch. Rather, you are here in this dark room and you're trying to figure out stuff about R. And the second reason, and I think this becomes increasingly relevant now with the tidyeval, is that even if you're an interactive user, you will slip into tool design sooner or later, because it makes your own life a whole lot easier, right? So if you do repetitive tasks, you probably want to write a function for that. And if you do repetitive tasks with dplyr or with data table or whatever, you probably want to do wrapper functions around that. And you are really, really well off knowing some non-standard evaluation, because you can provide yourself with that same convenience that the domain-specific languages do. So something non-standard, there should be something standard, probably. So let's think about and have it clear what is standard evaluation. So we all create variables, I guess, by assigning some kind of value to a name. And this is how we bind a value to a name, and this happens in an environment. So if you didn't specify a specific environment, this is just a global environment. As soon as you start up your R session, you reside in the global. And to retrieve the value of the variable, you evaluate the name. So evaluation is giving the name to the R session, and then it retrieves the value that's belonging to that name. And lexical scoping, who's familiar with that? The term? Yeah? So that's basically where to look up your value. So if you start a new function, here we have the function afunc, and it doesn't take any arguments. And the variable x resides both in the local environment of the function and in the global environment. And as soon as the function is called and x got evaluated, then it first looks up in the global environment. So you see that the value belonging to x in the local environment is called a variable in the local, and the other one is global, a variable in the global. I'm sorry, mixed that up. So x gets evaluated, and then first we look around, does x exist in this local environment? Yes, it does. All right, then we return that. Now, if it doesn't, we move up a level to the parent environment, and that's the environment where the current environment was created. So here we do, to decomplicate things a little, we use z. So z does not exist in the local environment, but it does in the global, which is the parent environment of the local environment, and there we look it up. Right? And finally, if we evaluate this value, so we create the function nobody loves me, and it evaluates the name y, and there is no variable called y, both in the local environment of the function nor in the global, then we throw an error, and then because we cannot find the object y. Everybody with me? This is fairly, well, it is standard, so it's fairly standard, right? Yeah, it's not fairly standard, it's completely standard. So that's standard evaluation. And I'm already starting to lose my voice. Now we can create name objects. And what's that? So a variable has a name, but we can also create objects of class name. And now it seems a little bit trivial, but I'm building up slowly, so I hope to keep you guys on board. So we apply the quote function, which is in base R. And then we basically create a variable to be evaluated later. So we postpone judgment, so to say. And to make things nice and complicated, there are two names for a name variable. You can also call it a symbol. So it's always nice if you learn something new and there is some ambiguity. And like everything else, so we create a name object. We can store that in another variable, just like we can store a character object in a variable or a data frame. We can store that in another variable. So here the quoted var is a regular variable. This made me a little bit inconvenient I did here. But so the variable quoted var is a regular variable containing quote, wait for it, so it's a name object containing it. And we have to actively evaluate the quoted var to instead of just calling it. So if we were just calling quoted var, then it would return a name object. If we run the eval function on it, then we actively evaluate this. Well, we judge this postponed judgment, so to say. And the funny thing here is that the wait for it variable was already created in a name object. It was stored in quoted var. And we can assign a value to it later and then evaluate it and retrieve this value. Well, this is probably the question you're asking now, right? I mean, this is a lot of back and forth storing the variables. It's a little bit fuzzy. Why would we want to do this? Well, because we can create a name object, postpone judgment, store it for later, and then evaluate in a different environment. We're going to look at an example. Everybody knows this function, dplyr pool? Who doesn't? Perfect. It's basically selecting one column, but then giving it back as a vector, right? So the select function always returns a data frame. So if you select one column, you would still get back a data frame of one column, but pool gives you a vector. I think everybody knows that conceptually, right? Okay. Now let's do it ourselves. We have a function x. No, we have a function dypool, sorry. We have the argument x, which is the data frame. So that's the thing you pipe in probably under normal circumstances. And we have, as the second argument, we have the name. So it's the name object. And now we run the eval function on the name in the environment x. And it works, right? So we quote the cylinder, we create a name object, and we evaluate it in the data frame. So apparently, a data frame is an environment too. I'm not really sure how this works because I'm not an expert on environments. That's the other nagging thing that I still have in me that I still want to sort out when the baby's asleep. And but we can eval this name object within the environment of the data frame, and the name object, so the column names are apparently responding like regular R variables. This is the next problem you have probably, because we have to quote ourselves here, right? So we have to quote the cylinder column. With your permission, I'm using the empty cars dataset, even it's full of errors. Yeah. Because I hate Iris, and it's either Iris or empty cars. So who hates Iris too? I just hate Iris. Yeah, yeah. I just can't stand the capitals and the dots in the column names. And it's, yeah. And you would think, well, if I'm using these lovely dplyr, data table, ggplot functions, I never have to quote myself. I can put in the bear. So if I use my own, if I write my own wrapper functions, I probably use quotes around the names I want to retrieve. So now I'm ending up with another burden by having to quote, by having to create this name objects myself. And that's what I was telling. So here I have the sale column in each free, and this should throw an error, right? If you think about it, it should throw an error, because we're actually calling some function, and we are asking for the sale variable. So we're actually asking for the value containing that belongs to the sale variable, and there is no sale variable in the global. So why does it still work? So anybody, would you think this is the way to do it? Could anyone take a guess what happens when we do this? Would it work or wouldn't it work? It will work? Why? You were just hoping that I move on, finally, yeah. It wouldn't. Why wouldn't it work? Because we quote the name of the argument. We don't quote the content of the argument. We quote, so we're going to look for the column name, bare name, in the data frame. Why? That's what quoting does. It's just creating a name variable out of the thing we provide it with. So it fails. We need another function here, and that's called substitute. And what substitute does is, instead of quoting the thing we provide it with, so the actual argument name, it quotes the content of the argument. So here in the substitute example, you see that it actually gives back the sale name object instead of x, right? If we would run quote on this, it will return x. And we see this is of class name. So this is how we can actually reproduce the pool function from dplyr by supplying the function with the data frame and also with the bare. I'm not sure if that's even a word, but that's how I always call it. So the bare column name SYL, sale. Second holiday picture. So this is how we could do some non-standard evaluation functions in R. How we can make those functions ourselves. And this is base R, of course. And I was not content by just knowing how it works, but also why it works. So why does this even work, right? So it still feels a little bit strange, and that's R's laziness. This is a koala, instead, in case you didn't know. And these babies are fucking lazy. They are in treetops. Simon, you can tell, of course. And we were taking this hike in Australia, and I'm sorry for swearing. Shouldn't have done it. And we were taking this hike in Australia, and actually somebody wrote with a stick on the gravel road, koala, with an arrow. So left, look up. And indeed there was a koala. That's how lazy they are. They're just like, they're total fluke of evolution. So some people think they're cute. I just think they're useless. And so we create the function koala. And we do it in this way. We create a function with two arguments, x and y. We take x and we add 42, and we run it on 3, and it works perfectly, right? We didn't even provide y. Y doesn't have a default value. R doesn't make a fuss. R couldn't care less. Works for you. You create extra arguments. I don't care. So R is really lazy. R is like this kid sitting in the back of the class doing weed during the breaks, and doesn't really make a fuss until it really has to. So different for Python. So Python is basically sitting in front of the class, pointing out errors that the teacher makes on the blackboard. This real obnoxious kid. Because Python, this is the exact same thing, right? I don't know much Python, but I can make a function. So it starts nagging before it even started. Well, I suppose you're supposed to provide me with y. There's no y. I'm stopped right here. I'm not going any further. That's all the Python you will see today, at least in my presentation. So R is lazy. So R doesn't give any errors or any doesn't make a fuss until it has to. And we cannot just quote names. We can also quote calls. So that's actually function calls. So think dplyr filter or the filtering you do in data table, where you actually give function calls. So if you say x is greater than 3, that's a function call because the greater than is an actual function. And there's also parallels, which everybody says I shouldn't bother about. It's something from the past. And there's literals we can quote, and that just evaluate to their same value. So like if you have a character, the character value a or something that quotes to itself, so that's not really interesting. And to collectively, they're called expressions. I listened to this song in preparation of this talk, and there's actually the line, "Don't be another sequel" in there. Did you know that? In NWSA's Express Yourself. So I'm actually thinking that NWA is talking about non-standard evaluation here. I'm not sure, but it's my sincere conviction. So just like a name, we can have a function call. So I'm not going over everything here, so I'm jumping a little bit straight to it because we already had the gentle introduction with the names. And we can substitute the call, but we need a little bit extra work. So now we have this thing that actually results in a logical. So we store that logical in retain row, and then we filter the data frame. Is this a bit clear to everybody? Yeah? Everybody has a gut feel of how it works? I'm going to put on the slides, of course, on GitHub, so you can read it over. It goes too fast. This is another song I listened to, and this is even worse. This is actually... I'm going to talk a little bit about promises, but you cannot really read it, but it's a promise you made by Cock Robin. It's really bad. But it was stuck in my mind when I was still reading about promises. I'm very, very sensitive to music when I read iCode. So I want to talk a little bit more about the laziness of R, because I think it's terribly interesting. So I hope you think too. Why does this work? So how does this laziness work? And that's where we get in the promise. It's probably a word you come across into some error message or something, but you don't know really what it is. And I really dug this up from the R implementation manual, which is, well, not a fun read, but it's really, really useful at times. And basically, each argument, so as soon as you call a function, each argument of the functions is getting, well, divided, it's not a good word, but it's getting a promise assigned to it, and it contains 3 slots. It contains the environment in which the argument was called, so that's where, I think that's for reference, for if you want to look up a variable. It contains the expression, so the actual expression, the quoting of the thing you put in the argument, and the value of the argument. So that's actually the result of the evaluation of the value. Now here's the fun bit, I think the nifty bit, is that the value slot is left empty. So only as soon as the argument gets evaluated within the function, then we start to actively evaluate the expression that's in the promise. And we store this expression into the value slot. So that's only if. If we do never, we will never throw an error, even if it's not a valid variable in the standard evaluation. So we're going back to koala again, that lazy bastard. And for the x value, so this is at creation. We have the so at creation of the promise, as soon as we call koala with x is x value, the environment is the global because that's where the function is called, and the expression is x value. So that's the name object x value, and the value remains empty. So as soon as the function hits the evaluation of x here, only then it will start to look for the value associated with x value, because that's the name object that was created for the argument x. So for y, this evaluation never happens and it never throws an error, because we never start looking for the actual value belonging to the name of y, the name object y. So that's how substitute works. Substitute enters the expression slot of the promise, and it never touches the value slot. So it never makes the expression evaluate. Right? Everybody with me here, or am I good? And by the way, you see here dparse, which is very helpful. For instance, if you want to create labels for your plot. That's how those plot labeling works. So if you do plot x and y, and you create a plot, and then on the x-axis is x, and on the y-axis is y, or whatever the values go in. So if you do plot value 1 and value 2, then value 1 and value 2 appear on the axis. That's how it works, because it's substitutes. So it enters the expression and then dparse, which is creating a character out of the expression. So a little bit about tidyeval. So I was under the impression that most people thought it was mainly on tidyeval. It's not. Tidyeval is the reason I dug into non-standard evaluation at this level, because I was, well, as everybody else, probably struggling creating tidyeval functions, because in the beginning the documentation was very, well, spread out, so to say. So it was not really clear what was where. So that's why I also did a little blog post, tidyeval most common actions. So if you would like, if you are struggling with tidyeval functions or creating tidyeval wrapper functions around dplyr, then that you might find it useful. There will be a link on my final slide. But a little bit on tidyeval. So everybody who uses data table, this is time to do something for yourself, but it's only a few slides. So tidyeval allows us to create these wrapper functions around dplyr code, but also other packages from the tidyverse. And but will be just using dplyr examples here. And now with everything we've just discovered about non-standard evaluation, maybe we can look into tidyeval now and try to understand that a little bit on a deeper level, which might also help you to write the tidyeval things with well, a little bit more understanding. So we have the function select from dplyr. Nothing new here. So apparently we now know that there's some kind of substitute going on under the hood of select. There's some select function somehow does the quoting. So I haven't done a deep dive into dplyr code yet, but that's something we assume for now. And now we want to do a wrapper function because we want to parameterize the grouping. So we would like to group by different variables, and we don't want to copy paste code because that's tedious and error prone, as we all know. So this won't work. Can anybody tell me why?
cards doesn't have a grouping bar.
Right. Yeah, so it is the exact same thing as when we applying quote to the variable, to the argument name within base non-standard evaluation. So group by takes the bare input of a variable, right? That's the whole fun of it. We don't have to do anything extra with it. It's very convenient to use interactively. But when programming, this won't work because the grouping var, so the entire dplyr framework will start looking for grouping var in the data frame instead of the content of the argument grouping var. So this is the riddle we need to get it to work. So we have to quote the variable up front. And then we have to unquote again when we enter it into the tidyverse function. And then that function will quote it again. So it's quote, unquote, quote. So this is working. We have the grouping var. And the quo function, the QUO function, that's the equivalent of quote, base quote. And then again you would think, yeah, well, this is not the way I usually call a dplyr function. I don't have to quote myself, like the crying baby boy. So there's also an equivalent of substitute in the tidyeval framework, and that's enquo. So basically what we do, we enter the bare column name, we quote it ourselves. So when we store this quoted variable into another variable, and then we unquote again with the bang bang. And then dplyr quotes again. So it's a bit of a hassle, but I think from the perspective we know now about non-standard evaluation, it kind of makes sense, right? So, yeah, doing all right time-wise. R is lazy, and that's a good thing. Just like we don't want to be Homer to be non-lazy, we don't want to be R non-lazy, because it allows for this creation of domain-specific languages, which is fantastic, which is why R is such a friend when using it interactively. And I have one little example, just to wrap it up, just to repeat everything once. So we create my filter, which is the equivalent of the filter function in dplyr, but of course dplyr has a whole lot of checking and stuff, but this is just a less intelligent brother. And we call it on a data frame, and we give the argument to that function bear call. Then bear call gets substituted, and we use that call to evaluate it within the data frame and filter the data frame with the result of that, because the result of the evaluation is illogical here. And the sil equals 4 here on itself is completely invalid R code because there's no sil variable in the global environment. But since we're using substitute here, R never starts to evaluate sil is 4 equals 4. Because substitute only enters the expression of the quoted call and is never evaluating it in a standard way. So after creating or subtracting the expression with substitute, we can evaluate it in a different environment. And in the environment of X, which is the data frame that was entered to the function, it's totally valid because there's a sil column and it actually responds like a variable. So some things that you might have expected to be in here, but it were not, because I really want to focus on the workings of non-standard evaluation, is quasi-quotation, which is a big thing in tidyeval, less or so in base R, but there's also the function bquote in base R. So that's unquoting a part of your quote, but not everything. So closures, that's also a big thing. That's how tidyeval differs from base R non-standard evaluation, is that with quoting also the environment gets saved, basically. So saved environments can go through other environments and still we can look up back where the closure was created. And as I mentioned, I'm not very big on environments yet. So that's also something that maybe could have been talked about more extensively, but it's not what I chose to talk about now. So thank you.